So one of the most important things that you want to learn from the polynomials equations unit is the factor theorem. This is probably, in my opinion, one of the most important things that you could take out of this unit because you can apply them to so many other things and you can actually use it to factor. It's like a new advanced method of factoring functions. So it says that if x minus b is a factor of a polynomial function of p of x if and only if p of b equals 0. And similarly, if ax minus b is a factor of the function p of x, if and only if p of b over a equals 0. So let's decode that. Like, what that looks like, a lot of like random unknown variables, and that makes zero sense to me. So let's use like an actual example for this. So let's say that we've got the function p of x is equal to 2x to the power of 3 plus 3x squared minus 3x minus 2. Okay, so we know that this is a function of p of x, and we don't really know anything else about the function right now, but we could learn a couple things from the next theorem that I'm going to get to in just a minute. But for now, let's just say that we have x minus 2. So we want to figure out if x minus 2 is a factor. So we know that x minus b is a factor of the polynomial if p of b equals 0. So we know that 2 is the value of b, but you can also just isolate for x. So 2 is x, and I guess it's also b. So you want to do p, and then it says p of b equals 0. So we know b is 2. So we'll do p of 2 equals 2, and then sub in 2 as b, or x, and then we'll sub that in for all of these. 2 squared minus 3, 2 minus 2. So then let's simplify this. P of 2 equals, so we're going to do 2 bracket 2 to the power of 3 plus 3, and then in brackets 2 squared minus 3, and that's times 2 minus 2 equals, okay, this equals 20. So p of b, or p of 2, equals 20. This does not equal 0. So we can say that x minus 2 is not a factor. So let's try another one. Let's do x plus 2, okay? So is x plus 2 a factor? Well, x plus 2, we want to find b, so we're going to isolate for x, so our b value, or x, is going to be negative 2 if this equals 0. So now that we know that our b is negative 2, we're going to do p of b, or negative 2 in this case, equals 2, and then we're going to sub in all of our values of x as negative 2. So to the power of 3 plus 3, negative 2 squared, minus 3, negative 2, minus 2. P of negative 2 equals, then we're going to do let's do the same thing. Then 2, negative 2 to the power of 3, plus 3 times negative 2, and this is all squared, minus 3 times negative 2, and then finally subtract 2. And that does equal 0. So if that equals 0, then that means, yes, x plus 2 is a factor. So what we know, though, is that about polynomial functions is that there could be multiple factors, right? There could be multiple values of x if there's many roots to the function, because it could cross the x-axis, like, you know, many times. In this case, it could cross up to 3 times, so there could be up to 3 factors. So let's try another one. I haven't tried this one on my worksheet, so this could very indeed not be a factor, but I'm hoping that it will be. I just want to do one that's ax plus b, ax minus b. So we want to see if 2x plus 1 is a factor. So to find b, we just isolate for x. So we equal that to 0, and it's going to be negative half. So now what we're going to do, I think that you guys kind of can already guess what we're going to do. We're going to do p of negative half. And we're going to sub all of our x values in for this. I'm not going to write it all out again because that's just, I feel like, a waste of time. So now I'm going to do 2 of... Hold on, I thought that would work typing it in my keyboard, but it wouldn't. t of negative 0.5 to the power of 3 plus 3 of negative 0.5, and this is squared, minus 3 bracket negative 0.5, and then finally minus 2. And that does equal 0. So we can also say that 2x plus 1 is also a factor. So another important theorem that you have to know is the integral zero theorem, and this kind of branches off of the factor theorem, which is why it's all in one video. The integral zero theorem says that if x minus b is a factor of the polynomial function p of x, and it has a leading coefficient of 1, and all of the remaining coefficients are integers, then b is a factor of the constant. So what does this mean? Let's decode this as well. So let me do another example with a function. So p of x equals, and then we'll do x cubed plus 2x squared minus 5x minus 6. Okay, so let's decode this. So we know that x minus b is a factor. So what we did in the last page, we already got different values of b and different random factors that we want to see if they were factors or not. But what if we're given this and it says to determine the factors? How would we do that? We don't know what the factors are, so we have to test different things, and we can test different things, or we can test things that make sense to test using the integral zero theorem. So let's look at this first. First of all, let's make sure that we can actually use the integral zero theorem. So has a leading coefficient of 1. So does this have a leading coefficient of 1? And yes, it does. It's not shown there, obviously, because it's just a 1. So yes, it does. And then the remaining coefficients are integers. So this just means that all of the other ones are whole numbers. So it can't be like a fraction. It can't be something with like pi or cos or something irrational. It has to be a whole number. So we got a 2, a 5, and a negative 6. So yes, these are, in fact, integers. So now we know that b is a factor of the constant. So the constant is just something that doesn't have an x on it. So this is negative 6. And it's saying that this will that our value of b, so the root, if the root is in x minus b form, or the factor, then we know that the b value is going to be something that can be multiplied to reach negative 6. So we've got 1, 2, 3, and 6. Those are the only factors that will multiply out to negative 6. So, and this can be a plus or a minus. These could all be plus or minus, actually. So we know that one of these has to be the value of b, and then to figure out which one's the right one, we're gonna test it out and see if it equals 0 or not. So let's do positive 1. I mean that's what makes the most sense to me. Like, let's just go in order. Let's do positive 1. So x plus 1, is that a factor? So equal that to 0, and our value of b is going to be negative 1. So let's do p of negative 1 equals, and then I'm going to sub in all of my x's as negative 1 to negative 1 squared minus 5, negative 1 minus 6. So p of negative 1, and I'm not going to type this one in, This it's to the power of 3. It's odd, so this is going to be a negative. Plus, and then this is going to be positive, and this is going to be plus 2. This is going to be plus 5, and this is going to be minus 6. So p of negative 1 equals negative 1 plus 2 is 1. 1 plus 5 is 6. 6 minus 6 is 0. So it does equal 0. P of b equals 0. So x plus 1 is a factor. So the last theorem that I would say branches off of the factor theorem and the integral zero theorem is the rational zero theorem. And this is probably the most complicated theorem that there is that we learn in advanced functions in this unit, I'd probably say. So it says that p of x, which is a polynomial function of x, with integer coefficients, so they're all whole number coefficients, no fractions or irrational numbers, and x equals b over a is a zero of the function. So x is x equals b over a. That's a root. That's where it crosses the x-axis. Where a and b are both whole numbers, and a cannot equal 0. So basically means that again, there are whole numbers, and the denominator can't equal 0 because then it would be undefined. Then it means that b is going to be a factor of the constant term. A is going to be a factor of the leading coefficient, and ax minus b will be the factor of p of x. So this looks really complicated, but really it's almost the exact same as the integral zero theorem, but if there's a different value of a that's not 1. So if the leading coefficient is greater than 1, then you use the rational zero theorem. So let's give let's do the function 2 p of x first equals 2x to the power of 3 minus 3x squared minus 5x plus 6. So the first thing that you'd think to do here is, well, I would say that this is my a value, so I know a is going to be a factor of the leading coefficient, and then the constant term is 6, so our b is also going to be a factor of the leading coefficient, and I know that my root is x equals b over a. So what I'm going to do is I'm going to list all of my different things. I got a positive and a minus 1, a positive and a minus 2, and then a positive and a minus 1, positive and minus 2, a 3, and finally a 6. These are all of my different factors for a and b. So instead of just easily testing random values, this time we're actually going to there's so many different combinations. There's like a crap ton of them. So we're going to do p of, let's take the first one here, which is going to be positive 1, and then let's just do positive 1 and make it simple. It would be 1 over 1. That would be one possibility of what it could be. Then we're going to do p over, let's do negative now. So we'll do negative 1 over positive 1. So then we're going to move on to the next one. So it's going to be, let's say, positive 2. P of 2 over, and then we take the first term of this one. It could be p over 2. P of 2 over 1. It could be p of negative 2 over 1. It could be p of negative 1 over 2. It could be p of 1 over 2. It could go on and on and on. But if you just continue with this pattern, eventually you're going to find one, and usually you get one of the factors, and you can work with that like within, I'd say, the first 3 or 4 times, because usually it's pretty easy to find. So let's try a random one. Let's just try p of 1. That may mean I always start with positive 1. That's what makes the most sense to me. So let's do that. Let's do p of 1 equals 2, sub in all of my x's as 1, minus 3, 1 squared, minus 5, 1, plus 6. So p of 1 is going to be equal to 2 minus 3 minus 5 plus 6. P of 1 equals 2 minus 3 is negative 1. Negative 1 minus 5 is negative 6. And negative 6 plus 6 is 0. So one of the factors is going to be x minus 1, because this is our x value. So we gotta, if we wanted if we want it in factored form, then we'd have to equal that to 0. So we would do x equals 1. So then our in factored form would be x equals -1. So we know that this would be a factor